Hello, everybody. Thanks for joining us today. My name is Simon. I'm a business development manager here at AIC. And today, I want to talk to you about a new type of hyper-converged infrastructure. This solution is brought to us by AirDeck Technologies. Before we begin, I want to briefly talk to you about our traditional virtualized environment and the hyper-converged infrastructure. What is the difference between the two? So in the traditional traditional virtualized environment, usually you have a cluster of hypervisors and you have a different type of storage appliances attached to that cluster. According to a different type of applications, you would draw storage from different type of storage appliances. Now, of course, this is very flexible, but at the same time, it's complicated because the hypervisors and the storage appliances, they all have different hardware configuration and they all have their own user management interface. So not only that, you have to learn different type of user interface. When you need to scale your cluster, you need to consider each type of hardware independently. And on the right-hand side, you have the hyper-converged infrastructure. Here, the compute power, hypervisor, storage resources, network resources, everything is consolidated in the same server. Now, when you need to scale this cluster, you only have to add a server with the exact same configuration loaded with the same software. So it's very easy to scale. At the same time, there's only one type of user management interface. So you only have to learn this type of management to manage all your resources. This sounds very good, but it does present another problem because you still need to run your different type of applications, but now you only have one type of storage. Can this one type of storage fulfill all your different type of applications? With that in mind, AirDeck proposed a different type of hyperconverged infrastructure. This is aimed to combine the benefit brought to us by the hyperconverged infrastructure, at the same time also allow us to enjoy the flexibility offered by the traditional virtualized environment. In order to do this, we need to support three very important features. The first one is multi-tier storage support, and the second one is a configurable resiliency policy options. And the third one is heterogeneous hardware support. Let's take a look at the mainstream hyperconverged infrastructure. Usually this type of architecture consists of hardware hosts that come with predefined number of hard drive and SSDs loaded with hypervisor, and then you launch a storage controller VM or a storage service that will manage all the resources from different hardware hosts, combine them into a single tier cached pool. So, and then provide this pool to the virtual machines to consume. Two problems are presented. First one, as we mentioned, single storage tier for all different type of applications. The second one is that the hard drive and the SSD come as a predefined ratio, so this cache ratio is also not adjustable. Okay. So AirDeck proposes a different type of architecture. Here we do not use any cache mechanism. Instead, we pour the hard drives into a capacity tier storage pool, the SSDs into a balanced tier storage pool, and the NVMe SSD or the memory class storage into a performance tier shared storage pool, and provide these different pools to the virtual machines to consume. What is the benefit of this? So first of all, each application now is able to draw storage from different pool according to the application requirements. And not only that, now you can also draw different type of, different amount of storage from different type of media and combine them into, for example, you can draw some amount from the performance tier as the cache disk, and then you draw some storage from the capacity tier as the data storage. And this ratio between the cache and the data storage is fully configurable by the users. And all these are made possible by our proprietary resource scheduler. So you can just configure whatever resource you want from whichever tier that you want, and then leave everything to the resource scheduler to find the appropriate host to launch the VM. A second very important feature that AirDeck support is the configurable resiliency policy options. Now, the mainstream, most of the mainstream hyper-converged infrastructure only support the scale-out storage, but sometimes this is not enough. So on top of that, AirDeck also supports a local single copy option and a close coupled or replicas options. And what are the differences between these all different options? So a single local copy VM disk that can provide the highest performance but no protection. So basically just a single copy of your VM disk resides on where the virtual machine is running. So when you write or read from that virtual machine disk, there's no latency from the network side, right? And but there's no data protection, okay? But this is perfect for some ephemeral storage requirement or and for some calculation that you just run and dump the source data, etc. And for people who require some protection, they can choose the close couple. Here, user can define the number of replicas to protect the data at the same time with minimum performance penalty. But also you have to spend more disk space because whenever you save the data, if you configure 2 or 3 replicas, the second copy of that data or the third copy of the data will be returned to the second or the third nodes, right? But the data is protected. And the last one is the erasure coding or general scale out storage option. This is also offered by most of the mainstream hyper-converged infrastructure. And it uses a user-defined EC ratio to protect the data with the minimum sacrifice of disk space, but at the expense of the performance. So you can mix and match all these different type of media and storage medias and the configurable resiliency options, and then create the type of virtual storage that fit the best to your application, okay? And last but not the least, we also support heterogeneous hardware support. So this means that you can expand as you grow. So for example, if you run out of hard drive capacity on your original cluster, you can just add a new host with hard drive only. You don't have to add NVMe or SATA SSD, even if you don't need it, right? You can just add a host with hard drive only. And this also means that you can mix old and new. So for example, if the next generation Intel platform Eagle Stream comes out and you want to be able to use that, you can just add a new node with this new type of CPU into your original cluster, even though your original cluster still uses older generation CPU, it's also supported. So this means that this AHCI, this new idea, adaptive hyper-converged infrastructure, basically means that this is a new generation of hyper-converged infrastructure that is capable of providing composable storage solutions to adapt different application scenarios and still keeps all the management advantages brought by HCI. So this is not only an adaptive hyper-converged infrastructure, it is also an application-centric hyper-converged infrastructure. So now we are going to talk about the hardware that is provided by AIC, and together with AirDeck technologies, we combine this very compact AIC server platform with their software, and we offer them as an appliance to our customers. Now, our business development manager, Arthur, will briefly talk about our hardware here. Arthur.
Hello, good morning, everyone. My name is Arthur from Cloud Data Center team. Today, I'm going to introduce our latest multi-node server, HP 202VL. Okay, this is our 2U 4-node server. Let's take a look at the front window. There are 12 bays, support 3.5-inch hard drives. We also have another model, suppose 24 bays, 2.5-inch hard drive or SSD, or NVMe SSD. Okay. In the red mount here, you can find the control panel. The control panel for 4 systems, 1, 2, 3, 4. Okay. And let's move on to the middle of the server. We have 5 easy swap fans in the middle. Each fan goes with the anti-vibration design. It gives you the good ventilation, and you can remove the fan very easily, and also reduce the fan noise. Another good design is we have 8 SSD here. Can you see that? Okay. This 8 SSD to support each node. More choice of the storage. Okay. And let's go to the rear window. Here is the redundant power supply. We have 2 kinds of redundant power supply. One is 1,600 watts. The other is 2,000 watts. Okay. Let me pull out one server node for you. Okay. Each system supports 2 Intel Xeon scalable CPU with 16 memory slots. Okay. In each system, we also provide 2 M.2 SSD here for your OS purpose. In the rear window, you can see we have 3 8-in car here, 2 in the upper side. This supports PCIe by 16. Okay. The third card is in the bottom. Let's support OCP measuring card. Okay. So no onboard network port, because we give you the flexibility. You can choose from 1G, 10G to 100 gig. Okay. So in summary, our latest multi-node server combines 2 kinds of storage, hard drive and SSD. Okay. Second, we give you the flexibility. You can choose a network port you demand. Okay. So I finished my introduction, and let's go back to Simon. Thank you.
Thank you very much, Arthur, for your very detailed introduction on our appliance. Right now, we ship 2 different configurations. The first one is our AD202VL Lite, which is our entry level, and it will be shipped with 3 nodes per block. So only 3 nodes will be populated, and also installed with the AirDeck Express version, which will allow our user to expand up to 16 nodes. The standard version AD202VL comes with 4 nodes per block, and will be installed with AirDeck Enterprise version, which will allow our user to expand the cluster up to 256 nodes. Also, the standard version will offer NVMe SSD. Now, I want to switch to our live demo. So, okay. So as you can see, when you first log into the user interface, you will come to this dashboard where you will see the number of nodes and the number of departments, and you will network utilization and your storage resources and utilization. This cluster, we do not have any NVMe SSD installed, so there is no performance tier on this cluster. When you expand the menu, first you will see departments, because our solution supports multi-tenant. So each department is like an organization or a company, and all the resources under that department is isolated for that department user only. And then you will see nodes, networks, and storage. These are your physical resources. And for virtual machine, virtual network, and virtual storage, these are your virtual resources. So in department, we have project groups and users. So first you can create a department, which is, as I mentioned, an organization, and create different projects under that organization. Sometimes you can also assign projects across different departments, and you can create users under the project, and also group the users together, right? The users sometimes can also be assigned to different projects across the different departments, etc. For users, we have a granular user privilege. So when you create a user, you can assign different type of user role, for example, admin, member, or observer. So a admin user are able to change configuration. A member can use the resources. The observer will only be able to look at, monitor the utilization, and look at the different settings, etc. They will not be able to do anything physically changing the settings or the environment, okay? So for the physical nodes, right now we have 3 nodes inside our cluster. And if you click on one of the nodes, you will be able to see all the hardware information on that node, including different components being installed on the nodes right now. Okay. So physical network, right now we have 2 different physical network. Each node right now has 2 different ports. One is used for admin network, and one is used for user network. The admin network is for the user to log in, change configuration, and monitor the status of the cluster. And user network is used for virtual machines to communicate with each other and to communicate to the external internet network environment. And the physical storage resource, we have a 3 tier, as we mentioned in the presentation before. But right now, this cluster doesn't have any performance tier storage. So as you can see, each node right now actually has 1 SATA SSD installed and 2 spinning hard drive installed. So together, the entire cluster has 3 SATA SSD and 6 hard drives. And they are the member of the balanced storage tier and the capacity storage tier. Okay. This is where you create your virtual machine and manage your virtual machine. For example, when you can create a virtual machine, and you can select the type of image that you want to launch the virtual machine from, and select a storage pool and a virtual network to use. Security group is a virtual firewall. Number of virtual CPUs and memory size, and also the storage volume size. Okay, create. It will take a while to launch the VM. So other options are supported. For example, you can take a snapshot of your virtual machine and roll back. So you can set up a snapshot policy, for example, automatically take a snapshot every day so that if you need to roll back to the previous day, you can also always have that option. Virtual machine image is where you launch the virtual machines from. So when I created my virtual machine, I selected one of these images. Here you can upload your image, and you can later launch your virtual machine from that image. Okay. So the other virtual resources, including virtual networks. So this is where you can create your virtual switch or a virtual router to connect different virtual network together. And a security group allows you to create security group security rules to limit traffic ingress or egress traffic to certain service ports. Okay. Virtual storage. So this is where you create your virtual storage. As I mentioned in my presentation, for example, you can create a storage pool. Storage pool. Let's say 3 copies, and you can select the type of media you want to use. Okay. For example, let's say capacity tier, and I want to 3 replica. So here you have options, right? A single copy means a single local copy, and 2, 3 number, these are the number of replicas. So if you have 3 copies, a second and the third copy will be created on the second and third node to protect your data. You also have option for erasure coding and the so different number of data bit or protection bit, but they cannot exceed the number of nodes. Okay, so here let's create this 3 copy data storage. So this is the virtual storage, which when you create a virtual machine, you can select from. Okay. So if I create a new virtual machine, now I will see that a new type of storage pool is available to me now. And earlier we created that virtual machine, and this is the CentOS virtual machine that we created earlier. Now it's already ready for us to log in and use. This is our introduction today. So if you have any questions, please let us know. And if you are interested in the solution, we also have a live demo environment set up for you to log in and test drive yourselves. Thank you very much for joining us today. And please let us know if you have any request. Thank you.